Hello guys! Today we are going to install Linux with a real full disk encryption and detached boot partition. This is a very hidden option in the operating system. We are going to put the cryptoheader in a thumb drive outside the computer. So let's proceed. Today we are going to install this on a relatively old computer. This computer is running with BIOS and the UEFI support is disabled. And then we are going to set up the BIOS password. This is the supervisor and user password required to boot the computer. And this is very important because you can boot a BIOS update and then install some type of malware there. So although this is not a bulletproof solution, this can mitigate or reduce risks of being compromised by someone with a very narrow time span on your computer. Another recommendation is to disable the hard drive boot, because you are going to boot from a thumb drive, not from the hard drive. So in the BIOS you never are going to need this option. Now we are going to boot into the Linux installation media. This can take several minutes. At this point, we are not going to click into install kubuntu. We are going to click into try kubuntu because we have to do some modifications before the installation process. Now it's time to open the terminal. We open the terminal and then we get into root using sudo. And then we list all the storage devices. We can see the hard drive and the thumb drive here. And then open a notepad, in this case Kate. We are going to write something here. And then in this path you can check for the device identificator. We are going to need this device identificator to the boot partition to recognize in which device the system is. So we copy the device identificator here. And then we have to create the partitions in the thumb drive, the boot partition in this case. We use fdisk to do so. The thumb drive is SDZ. Create a new partition with N. Enter all the defaults. we are going to remove the previous signature, and this, we're going to write the device. So the partition will be written into your thumb drive. And it's done. Now we have to create the root file system, I mean the root partition and the swap partition inside the encrypted container. But before, we have to create the encrypted container itself. So let's create the encrypted container. We are using Serpent XTS, and the key size is 512. The hash we are using is SHA 512 also. And the header will be detached from the hard drive. We are going to put this header in here, and we are going to create and then the encrypted container into the hard drive. You write yes for all the overwrites, and then write the disk password, the encryption password, and remember that if you install this, all the hard drive information will be wiped. Now we have the encryption header detached here. We can check the details, and the details says that the cipher is Serpent. The bits, the used bits for encryption for hash is 512, and this is good. Now we are going to open this device, the hard drive device. Open the encryption into device block called HD crypt 0, and we specify here the header. Without the header, you cannot open the disk. And then you have to enter the password. And then you are done with the encryption. Now we have to create the partitions inside the encryption. So Linux have a tool for this. It's called LVM, to create partitions wherever you want. So let's create the volume, physical volume, and then we are going to create the volume group 0 and the LVM partition for swap. I put size 8 gigabytes for swap. It will depend on your available space available on your computer, and how much RAM you have in your computer itself. And then all the available space left, all the left space, it's going to be the root partition for your file system. We are not going to create elaborated partition scheme, only root, swap, and boot. $100 for the root partition and 8 GB for the swap partition, and then 4 GB for boot partition. Now we are done with the partition scheme. Now we can proceed to install the operating system here. The installation is something pretty standard. We get into the installation dialog, and then we continue. And then we should wait until the installation and then we select our installation method. I recommend to download the updates while installing kubuntu. And then here in the installation type we click on manual and then continue. And now we select the root file system here with this slash and format the partition in VG0 root. This is pretty standard in all installations of this. We choose swap area for the swap VG0 swap, and then the other partition we have to create is /boot. Now we check that the device bootloader installation is the same that /boot. And then we install. This will take a while. Meanwhile, we are configuring some internals from the operating system, like the time zone and like the user and password in parallel while we are installing all the stuff. Here we click on continue testing. Do not reset. Now we get again into the terminal. We are going to mount the root file system, encrypted root file system, into this directory, temporary directory called target. Then we are going to mount the boot partition. We are going to mount 3 virtual file systems, which are proc, sys, and devices. And then we have to create a directory inside the initramfs builder configuration directory, which is inside the installation. This directory doesn't come by default in the operating system. It's called cryptoheader. And this directory is important because if you put the cryptoheader there and you do some modifications to the initramfs, then the initramfs will include in the cryptoheader inside the initramfs actually. Now we copy the cryptoheader inside the new directory. And we get into the installation using chroot. Doesn't matter the message name failed. We are into the installation. And then we have to create a symbolic link of this directory as a /conf, because the cryptoheader should be in the same directory inside the initramfs file system, and and the same directory and same file inside your own installation. Now we have to build the crypt tab file, which will tell the initramfs where is your encrypted hard drive and which files are defined for your encrypted hardware for encrypted hard drive. So we use the disk identificator to get into the disk. So it doesn't matter if this time your hard drive is SDC or SDD. This file will go for the identificator, not for the temporary name. Then we continue with none, and we continue with telling that this looks file system, discard, and we point to the header file. header is the cryptoheader file. It is important that the hd-crypt0 is the same name appeared in your installation, and then we continue. Our next step is to modify the initramfs tools. Initramfs comes with a hidden option which enable the system to copy the crypt header inside the initramfs. But this option is disabled due to security concerns. However, our purpose is to put the crypt header in the initramfs. Now we're going to edit this file. We are going to look for crypt header. And then we're going to look for some commented part of the script. This commented part is used to copy the header, the crypto header, inside the initramfs file. So now we have modified this. Now we are ready to rebuild the initramfs with the command update initramfs. It will take some time to rebuild the initramfs. And again, it will include all the crypto header information inside the initramfs, so you don't need to put the crypto header in another place. You have the crypto header inside the initramfs configuration directory, and it will be copied to initramfs inside boot partition. And since the boot partition is outside our computer, now the crypt header is also outside our computer. So if you could lose your computer, or someone takes your computer, it will be impossible to retrieve the crypt header, so it will be impossible to crack or reverse the crypto key, because the crypto key won't be in your computer at all. Now the initramfs is about to be completed. And we are done with this process. The installation is almost done. Okay, now we are going to log out the chroot, and then we are going to mount the target partition, all the target partition, I mean sys boot proc and dev partitions, and target itself. And then we can reboot the system in order to try our installation. Now everything has been installed. The Ubuntu installation asks for your hard drive password, which is the cryptoheader password itself. So we get into the Linux. We introduce the password, and now the Linux is booting for the first time. No errors so far. Everything is going smoothly. And this computer, remember, this is an Atom computer, which is very, very, very slow. We are going to get into the account, test account. It will take some time because this is the first boot, and the installation needs to configure some databases in your and files into your test account. Now we are logging in. And now we are logged into the operating system. Everything is working so far. And we are going to check that the encryption is working. By hand, like a forensic auditor. We are going to install the hexadecimal editor for this computer. And then after we install the hexadecimal editor on this computer, we are going to check for the hard drives, the thumb drive and the hard drive. Now we are ready to test. The hard drive, we are going to check which hard drive we have. So we see the encryption here, and here we see that the hard drive only contains random data, all the hard drive, all the containers random data. And the thumb drive does not contain random data. It contains defined partitions, it contains ASCII text, and also contains the cryptoheader. So you should physically protect this thumb drive. In Resume, we are using encryption with Serpent and 256 with XTS. The hash is SHA-212. The crypto header is detached in the thumb drive. The boot partition is detached in the thumb drive also. And we are using an old BIOS scam, which has inherent vulnerabilities. We also recommend to use the ban wipe in all the devices before the installation, and we are going to show you here which options looks options are available and are, in my opinion, the best for security. Cipher, I prefer Serpent. Hash, I prefer SHA 512. Key size is 512 because he's going to use the half for the Serpent encryption and the other half to some hash. I recommend you to use random device for the creation of the crypto header, because you need really random bytes to create a stronger encryption. And the iteration time is extremely important to prevent password cracking of your crypto header. Thank you very much.